Okay, now another topic which is called solubility and solubility product. Actually, this concept is applicable only for some salt and those salt which are sparingly soluble in water. Sparingly soluble means which are slowly soluble in water. For that type of salt, you can apply this solubility product concept. Now, sparingly soluble salt sparingly soluble salt, I mean it's slowly soluble in water. Sparingly soluble salt like silver chloride AgCl, barium sulfate BaSO4, calcium fluoride CaF2. This type of salts are called sparingly soluble salt because they do not dissolve in water properly. They dissolve in water very slowly. So that's why this type of salts are called sparingly soluble salt, and the solubility product concept is applicable only for sparingly soluble salt. Sparingly soluble salt like silver chloride, barium sulfate, calcium fluoride, when dissolved in water, etc., when dissolved in water, only a small amount of salt goes into the solution, while most of the salt remain undissociated. To become soluble, it should be dissociated. So maximum of salt remain undissociated, and that's why it is not properly dissolved in water. For example, suppose your salt is silver chloride, it is in solid state. When you dissolve in water, it produces a little ions like Ag plus. It will be aqueous. Aqueous means these are formed in water. Cl minus aqueous. Now when you write the dissociation constant K, as you know, dissociation constant is equal multiplication of the concentration of ions, I mean concentration of Ag plus ion aqueous into concentration of Cl minus ion aqueous divided by concentration of reactant, concentration of AgCl solid. Since solid substance concentration is constant, that's why you can multiply with K into concentration of AgCl. This is equal, you can write concentration of Ag plus aqueous into concentration of Cl minus aqueous. This K into AgCl you can write as KSP. SP means solubility product, and this is called a solubility product, KSP. KSP is equal concentration of Ag plus ion aqueous into concentration of Cl minus ion aqueous. So this is the process how to find out the KSP. So this KSP is called solubility product. This KSP is called solubility product. So what is solubility product? Solubility product means nothing. Solubility product means it is the multiplication of the concentration of ions of a sparingly soluble salt. It is the multiplication of the concentration of ions of a sparingly soluble salt like silver chloride, barium sulfate, like that. Now I will find out the relation between solubility and solubility product. To find out the relation, let the solubility of AgCl is S mole per liter. I mean S mole of AgCl is dissolved in water in 1 liter solution. That's why we have considered let the solubility of AgCl is S mole per liter. If S mole of AgCl is dissolved in water, then the concentration of silver ion will be S mole per liter. Concentration of Cl minus ion will be S mole per liter. So if the solubility of AgCl is S mole per liter, then concentration of Ag plus ion you will get S mole per liter. Similarly, concentration of Cl minus ion you will get S mole per liter. Ultimately, KSP, if you want to find out, as you know, KSP is equal multiplication of the concentration of silver ion and chloride ion aqueous. So Ag plus ion concentration is S, chloride ion concentration is S. Ultimately, you can write S square. That means you have got KSP is equal S square, or S is equal root over KSP. So this is the relation between solubility and solubility product for silver chloride salt. These are applicable only for sparingly soluble salt. So this relation we have find out for AgCl. If the salt is something different, if you consider another salt, then the relation may be different. It depends on the salt, what type of salt you have taken. If you consider another salt, for example, your salt is calcium fluoride, CaF2. You know, when CaF2 is dissolved in water, it produces the ions like this, calcium ion, Ca2 plus ion aqueous. Since there are two fluorine, that's why the ions will be 2F minus aqueous. Like this way you have to produce the ions. And you know, KSP means nothing, it is the multiplication of the concentration of ions. I mean, you can write concentration of calcium ion aqueous into concentration of F minus aqueous. Here coefficient is 2 na, it should be power like this. So this is the process how to find out the KSP. It is the multiplication of the concentration of ions of a sparingly soluble salt and its raised to the power equal to its coefficient. Like this way you have to define the KSP. Now, if the solubility of calcium fluoride we considered as S, then concentration of calcium ion will be S, concentration of fluoride ion will be twice S, because here 2 moles present. That's why if it is S mole per liter solubility, then concentration of calcium ion will be S, concentration of F minus will be twice S. That means you can write KSP is equal, if you want to find out relation between KSP and solubility, concentration of calcium ion you have got S into concentration of fluoride ion you have got twice S. Since one square present, that's why twice S whole square. Ultimately you will get S into 4S square. That means you can write 4S cube. That means S is equal, what you can write, KSP divided by 4 whole to the power 1 by 3. So this is the relation between solubility and solubility product for calcium fluoride salt. So that is why depending on the salt, whether you have taken silver chloride or calcium fluoride, based on that you will get different types of relation between solubility and solubility product. If the salt is silver chloride, relation you have got S is equal root over KSP. Similarly, if the salt is calcium fluoride, then the relation you will get S is equal KSP divided by 4 whole to the power 1 by 3. Similarly, I will take another example. Suppose our salt is calcium phosphate, Ca3PO4 whole 2. This is also one example of sparingly soluble salt, calcium phosphate. Now when you dissolve in water, what are the ions will produce? Here how many calcium? 3 calcium, na? That's why you have to write 3 Ca like this to produce the ions. How many phosphate? There are 2 phosphate. First time you write like this. 3 calcium, 2 phosphate. Now what will be the source? See, with calcium, how many phosphate? With calcium there are 2 phosphate, na? That should be the source of calcium, 2 plus. Similarly, with phosphate, how much calcium? 3. That's why it should be 3 minus. Like this you can find out the your ions from a salt. Now, if the solubility of calcium phosphate we consider as S mole per liter, then concentration of calcium ion will be 3S, concentration of phosphate ion will be twice S. Like this way you can find out the concentration of the ions. Here 3 moles present, that's why 3S. Here 2 moles present, that's why twice S. As you know, Ksp is equal multiplication of the concentration of ions, calcium ion equals coefficient 3, that's why whole cube, into phosphate ion equals coefficient is 2, that's why whole square. So these are in aqueous state. After dissolving in water, it will produce the ions. So calcium ion you have got 3S, it will be whole cube, into phosphate ion you have got twice S, it should be whole square. Now this become 27 S cube, this become 4S square. Ultimately you will get 108 S to the power 5. Therefore S is equal, you can write Ksp divided by 108 whole to the power, you can write 1 by 5. So this is the relation between solubility and solubility product for calcium phosphate. So like this way, based on the salt, you can find out the relation between solubility and solubility product. In exam, the solubility product value will be supplied to you for a salt. You have to find out the solubility. Similarly, solubility will be given to you. You have to find out the Ksp for the salt. So what type of salt is given, based on that you have to find out the relation between solubility and solubility product. After that you have to put the value. So this concept is called solubility or solubility product. Thank you.